Welcome everyone. I'm Matteo. I'm a software developer at Sant'Ambrogio, and today we're going to discover the news about NextGen 2023, along with a recap of the cumulative updates of the last 12 months. Just a couple of words before starting. Please keep your microphone off during the session, so we don't have any sound in the background, and the meeting should take around 45 minutes, maybe a bit less, and we are very pleased to answer your questions at the end of the presentation. And the meeting is being recorded, so you will find it on YouTube in the coming days. So what we are going to see today, we will have a look at the user interface updates that we made to the software recently. Then we will look at the codes and standards updates that we added to the software in the last year. And of course, we will take a look at the functional updates to the software. And in the end, again, questions and answers. You can write your questions in Teams, either in the chat or in the Q&A section that you find, and we'll check at the end eventually if there are questions written there. Another option is to open your microphone at the end of the session and ask directly. So let's start with the codes and standard updates. We didn't have a lot of updates during the last 12 months. We just completed the conversion of the ISME PTB test cases. So we now have PTB 4 2021 and PTB 3 2022 inside the NextGen as test cases for the ISME code. We implemented the latest 82,000 updates in different Merkblatts, and more are coming in the coming months. We updated the tightening torque according to ISME PCC. PCC1 updated to year 2022, and the gasket dimensions according to ISME 1620 up to the 2017 version. The good thing is that more updates are coming in the next year. This year has been quite not very busy in terms of updates of the norms, but the next year would be, and we will of course add the ISME BP VC 2023 to NextGen. We are already looking at it, and if you need a timeline, I think that we will ship a version of NextGen including this big update already in the last months of the year. We have WRC 2022 that is already completed and ready to be shipped. So the next version of NextGen will include this update. We are still unsure if we will release a new version before August, so at the end of July, just to fill the gaps left by our latest version 2023. So just to include a few updates to that version, or eventually we will release a cumulative update with both WRC and ISME later in fall 2023. And then we are waiting for B5 and B9 of AD 2000 to be published in English, so we can include that update as well. As for NextGen 2023, the biggest update that you probably have noticed is the user interface update, and we are continuing a progressive update of the NextGen user interface to make it more modern and more discoverable in terms of features. And we began this process in 2019 with the components editor. We then updated the item properties editor in 2021, and then the project manager in 2022 at the beginning of last year. And then this big update that we have included in the 2023 version that completely changes the user interface of the main design window. And now we can switch to NextGen and take a look at this update with a little demo. Okay, as soon as you start NextGen, you have the project browser. This window is the window that we already changed last year, and we added more features even in the last version. For instance, you can ask for support straight from this window. So even if you can't open your files, maybe you have some issues with your files and you can't open them, you can ask for support from here. Then we added some tools here, for instance, the ability to open your materials database from here, check for updates, and some diagnostic tools that may be useful if you have some issues and our support team ask you for instance, for the program log to be sent via email. So some small updates to this window. Then once you open your NextGen, you notice that we replaced the toolbar on the top and the menu on the top with this ribbon bar that is more modern, but the interesting thing is that we are now able to let you know when something, a feature, a component is not enabled, and the reason why that component is not enabled. So, for instance, I have an AD2000 calculation here with just a cylinder, and I'm trying to add a cone, and you see that my cone icon is highlighted in red, and the command displayed shows that this command is currently unavailable because my license does not include that. So we have an explanation of what's happening and why I can't use something. This is quite obvious. It was already present in the previous versions, but we have expanded on, for instance, here we have elliptical heads. Elliptical heads are not supported by the AD2000 code. So if I click on the elliptical head, the program explains that I can't add this component because it's not currently available for calculation code limitations. Same goes for other components. For instance, this one, brackets, you can see, let me zoom a bit in, that command is unavailable because it can be only available for vertical items. So I need to make this item vertical. Or again, because this component is available only for heat exchangers. So we have more a toolbox that explains why we can't do something, while previously we only had information about components and features that were actually available in that moment. There are some other features in this new window. For instance, once you select a component, you already had in the previous version the right-click contextual menu, so the ability to act on a single component by right-clicking on it, and now we have expanded it with this contextual toolbar. And for instance, from here you can of course make the component, hide the component or make it transparent, and the same goes from with these features here, or you can quickly change its color, for instance, if you want. And other contextual options are available here, like the ability to insert components between other components. And so this goes in terms of discoverability of the features that are available to you. You have all the features available to you, very visible within these menus. What else we have? Yeah, one final word with the calculation report. If I print the calculation report, now the calculation report is integrated in the same toolbar, so you can switch between the report and the components window. But if you prefer an approach like what we had with NextGen 2022, you can detach this window, and you have a separate window for the report, and a different window for your 3D environment. So that's it. I think this is a good update that will let you understand better what you can do with NextGen, and also maybe discover some more hidden features that were buried under the menus, and now are more apparent. Okay, let's close this item. Don't save it.
Sorry, Matteo, you have a question in the chat.
Okay, let me check. Why there is not possible to add legs and skirt in the same time? Of course, one of them will be used, but sometimes I'd like to check which way is better. Okay, this is by design, the fact that you can't add multiple supports on the same item. It makes it a bit difficult to manage which one is active, because, for instance, if you have both skirt and legs, the weight of one support would be added to the overall weight of the vessel, and act on the other support. So it would be a bit messy, I think. Also, in terms of user interface, you would see the two components. So my suggestion here is just to create your vessel, add one support, and then duplicate your calculation from the project browser. From here, you can duplicate from here, and then remove that support and create the other one. It would be a bit difficult to manage multiple supports. We are actually working on something that would let you create two different supports, one for the vertical vessel, and the other one for saddles for transportation, but that is a completely different story. This is, in that case, it would be for a different scenario, not to select which one is better between two supports, but to cover two different usages of supports. Okay, let's continue with the presentation. Okay, we have seen the user interface updates, and now I would spend a few words with about the usage factor. Usage factor is a feature that was present in NextGen since many years ago. We recently, in the last year, we have revamped it and polished it and make it more usable and useful. So whenever you see these links here, these are redirects to our help support website, so you can check more on that website. Maybe you can download the presentation later, and then if you're interested, you will find all this information on our website. So let's check the demo about the usage factor. So the usage factor basically is the feature that lets you understand how much material you are actually wasting, in a way, in your calculation, because sometimes you have a scenario like this one where I have 3 cylindrical shells, you see, and obviously I have this cylindrical shell that is not validated, so I expect this cylinder to have insufficient thickness. So I can just open it, and okay, the minimum thickness is 4. Let's see. Okay, 4 is fine, and then everything is okay. So in this case, I expect my calculation to be fine in a way. But if we dig deeper, we see here that we have this component that is using almost all of its material, and the same goes with this one. But if we check this one, you see that we are wasting a lot of material. This is how the maximum allowable pressure stacks compared to the design pressure. So it's a ratio between the two pressures, and we are actually using only 20% of our maximum allowable working pressure. So this happens because I have a thickness of 20 millimeters compared to the minimum thickness of 4 millimeters. So it's very obvious when you are under designing something with NextGen, because of course you have a validation error, and the best approach is to follow the direction given by the software and increase the thickness. But sometimes you are just making a checking of a file, of a drawing, for instance. So you input the value that is written on the drawing. So let's say the cylinder is 10 millimeters, but how much is 10 millimeters? How much more than needed is 10 millimeters? It's a bit more, because all the material between 4 and that was our minimum required thickness, and 10 is actually wasted, is not used to resist the pressure. So you are creating a more expensive machine, using more material, wasting more material, and overall having a more expensive project. So I highly recommend you to check this feature out, because it can be very helpful. Also with the nozzles, you have more information. In this case, we have the nozzle analyzed as a cylinder or as an opening, and obviously it is the opening that is guiding the process. So if you have this kind of chart, maybe you can decrease the schedule of your nozzle and use a lighter pipe. And the same goes for flanges. In this case, is a flange calculated according to the standard, not a standard, but with code rules. So in this case, we have the flange maximum allowable pressure and both some maximum allowable pressure that are quite high. So we have a lot of material that is actually wasted. We can decrease the rating of this flange and use a lighter flange. And other than the usage factor within the component window, we also have the global usage factor. Under tools, you can use usage factor here and add one or more components and see how they stack one against the other. So we have these 2 cylinders that are almost using almost all their material to resist pressure, while the other one, the C3, that is cylindrical shell 3, that is oversized. Okay, we have a couple of questions. It is possible to import files into NextGen from other pressure vessel programs? I'm afraid no. This is something that depends on every producer of software. We are kind of jealous of our file formats, so it's not very easy to interchange files between one another. Does usage factor compare to maximum allowable working pressure of the vessel or to the design pressure of the component? That's a good question. I think it's the design pressure of the component, because you usually have the same pressure for the component and for the whole item, but could happen that you have different pressures there. Let's see what happens if we change the design pressure here and go down to 1 only on this component. Yes, it changes. So the component checks the ratio between the maximum allowable working pressure and the design pressure is on a per component basis. Okay, that's it for the usage factor. And let's see what else we have. Okay, calculation report. In terms of calculation report, we have made a lot of improvements in the last year. And we have now, first and foremost, the ability to produce a report using the current code prescribed units. This was available in a way in previous versions, but now it's more explicit. So if you want to stick to the units that are available for that specific calculation code, and I'm thinking about 82,000 using VAR for pressure, while other codes use megapascal. You can do that. We have the printout of the local loads transposition to the support. This is available for vertical vessels, so vertical supports like legs and skirts. So if you have local loads applied to some of your nozzles, these loads are transferred to the base of the support, and now we have a page that shows you how these loads are transposed to the bottom of the vessel. We then have the printout of the weights details. This is an improvement over the previously available weights page, and it shows every component's own weight, how this weight is transformed to go down to the support again, and how it is transformed according to the coefficients available in the load combinations. Then we have a summary of the item properties and the calculation options used to calculate a certain item, and a summary of the load combination properties. Let's see it in action. Okay, report. So I have a vessel on legs here. And as I said, one thing that you can do now under tools and options and reporting for the units, you can stick to the calculation code default units. And this is an explanation of the list of the default units for each calculation code. Then we have, let's print the global report and check on that. Okay, this vessel has a nozzle here, and the nozzle you can see from the icon that you can activate by using this button here. You see that it has WRC enabled and local loads. So if we check the report, we have now the nozzle transposed loads. So this is the transposition of the loads acting on that nozzle down to the support. And this should be available also for horizontal vessel on saddles in the near future. Then we have the weights details. Okay, weights page has been greatly improved now. You have the list of the components, and for each component, let me zoom in a bit. For each component, you can see that, for instance, here for the wedding neck flange number one, we have included the weight of the bolts, and this is in kilograms, so 24 kilograms of bolts. And we have asked to not consider that weight in erection. This is something that you can manage from the weights page, weights category of the component. You see here, I have added 10 kilograms of dead weight, and I have asked not to consider that weight in erection. So we have these features reflected in our calculation report. And then what else we have here? We have the transformation of the weights due to the load combinations. So I have added or changed that dead weight factor to 1.1 for the operating condition. And again, you can manage your load combinations from here, edit. And you can see here that I have, where is that? Here, 1.1 as dead weight factor. So if I see my weights increased in the operational load combination, it is because I have multiplied each weight for 1.1. So I have a more precise way to explain why my weights are changing when transferred to the bottom of the vessel. And we also have a recap of the item properties. So these are the properties that you set when you set up your item, which test is enabled, if we included or not some of the options. And this can be helpful if you want to recheck items in the future and see how you manage to set them up. And finally, we have revised the load combinations recap. So you have this summary with the load combination, explanation of the symbols, and a recap of the factors of each load combination. So this is again a progressive update of our calculation report, and we are including more meaningful information, and especially in the structural calculation ways to better understand how the vessel is behaving and how each load weight is transferred down to the support. Okay, I'm checking. Is it a couple of questions? Is it possible to change the way loads are transposed? Some clients ask to transpose the loads using their own formulas like square superposition or reduction factor depending how many nodes are combined. At the moment, we can't change the way the loads are transposed. We are using AD 2000 method. Maybe we can check for the future if it's possible, or keep in mind that you can always override the calculation that we make for each load combination from here, and override automatic calculation. And of course, you lose everything, because not only the local loads, but every other load calculation. But this is an option that you have.
Sorry,
question?
I want to add something, Matteo, in the load combination details window.
Yes, please.
If you click on edit, you can actually choose the combination method of external forces from SRSS to algebraic sum. So we added this recent improvement to allow also the algebraic sum and not the square root of the sum of the squares. So
okay,
this is possible.
Okay, great, thank you. By the way, this is Paolo, one of my colleagues from the office, and There is another question. Why can't we add coils to the conical part? Well, basically, the answer here is that it is pretty difficult to draw the actual model of the coil around a cone, but I think that eventually we will add that feature too. Okay, let's see what else we have. Improvement to rectangular vessels. And so here we were lacking externally reinforced vessels under Division 1, and we added at the beginning of this year. So we now have a complete coverage of both internally and externally reinforced vessel in ISME Division 1. Then we added a bit subtle feature that is the option to select which method to use to calculate the minimum thickness of a rectangular vessel face. So we have, this is displayed in the image below. So we have different methods to calculate the minimum thickness of the vessel face. This happens because the rectangular vessel method doesn't give you actually a minimum required thickness, but gives you means to check stresses in different points of the vessel, and so we have to come up with a trick to calculate a minimum thickness. This is especially useful when you are calculating openings, because openings use the excess thickness to reinforce said opening. So you have the ability to select which method you want to use. And then we extended the support of screw clamps, inched bolts. So every mean of locking that is placed outside the boundaries of the flange itself for rectangular flanges. Rectangular flanges are available in NextGen according to the PD 5500 method, and are available in every calculation code. We made small improvements to the custom bolts. Again, this is part of our progressive improvement of usability of the software. So you have now the ability to quickly copy a standard bolt into a custom one. This is a very needed feature, because otherwise you had to fill all the values by yourself, even if you wanted to change just a little bit of values from a standard bolt. So you can copy that from the standard database to the custom database in the same way that it happens with what we already do for custom materials. And then we added the pitch property to be customized, and the resisting area customization. For jacketed vessels, we made improvements in that area too. Especially we added the inlet and outlet nozzle support for the half pipe. So if you have a half pipe, of course you need to add a couple of nozzles to insert, and for the inlet and outlet nozzles for your fluid. And in that case, it wasn't possible before, and now it is possible. So you can add two nozzles, one at the end and one at the beginning of the windings. Then we added a couple of options for the additional components, so the non 3D components that let you specify if the additional component that you are designing is part of the jacket or if it is covered by the jacket. This helps you in determining the design condition for that component, because if it's under jacket, the program automatically made the adjustments to the pressures to take that into account. And same goes for the if the component is part of the vessel, it takes the design condition of the jacket and not of the inner vessel. We have a number of updates for the non-pressure loads. So we added the ability to add a customizable load set manageable with Excel. In WRC, we added a API 660 as a load set. we then added a property to specify how WRC affects the calculation of the maximum allowable pressure for each opening. We changed the WRC moments default unit to Newton meter compared to Newton millimeters that were available before. Then we added the ability to define a custom area for the snow, loaded by the snow. We added a new component that is forces called the forces and moments that let you specify an arbitrary positioned set of forces and moments acting on a vertical vessel support. And again, this eventually will be added also for horizontal vessels. And we now have the ability to connect flange lugs to reinforced rings for to move your vessel or to erect it, and the ability to connect lifting lugs on flat covers. Remember that WRC is not available for attachments on flat covers, so you only have the ability to calculate the dimensions of the lifting lug and not the actions of that load on the flat cover. Let's see something in NextGen about this. So the first thing that I want to show you is the fact that you can create, you can customize an Excel file that we have included. And you can find it under Tools, Options, by opening this folder. You see here that the program created a nozzle loads file, and I have inserted these values here for the DN100, and now my nozzle here is using WRC with a custom Excel file, and it loads from that file my my specified load set. So we have this nice feature that lets you customize the load set that you're using, and of course we have other standards included, including API 660, that is the latest addition that we made. Then for each nozzle and opening, again under WRC, you can see that we can consider WRC in the determination of the opening maximum pressure, and on each opening we can select if WRC affects the maximum allowable working pressure, the maximum allowable pressure, or none. As for the snow, under the item properties and under loads, you have now the ability to specify both the snow load and the snow area. If not specified, it's just the surface, the visible surface from top of the vessel. And as I said, you can now add lifting lugs on covers and flange lugs on this type of nozzles. This is a nozzle where I have specified that under geometry, that a blind flange can be connected. So this is a studding outlet or a reinforced ring, and then you can add a flange lug to erect or move this item. So a nice set of new improvements in terms of non-pressure loads.
Sorry, Matteo, you have a couple of questions.
Oh, let me check. Okay, regarding WRC of attachments, standard vessel pressure is set to 0. In my opinion, it would be useful to be able to copy components pressure. Standard pressure is set to 0? Sounds strange to me. We usually include the pressure in the calculation and let you override that. Yes. Here in this vessel, I have a pressure of 0.5 megapascal, and it is considered. Maybe you are not talking about nozzles, but attachment. Okay, yeah, square attachment, not the nozzle. We can look into that. I'm not sure that it must be considered. We can look into that and eventually behave in the same way that we behave with nozzles. Okay, thank you for the suggestion. Maybe may we use many Excel files for custom nozzle loads or only one? Okay, out of the box you can use one, but nothing prevents you from swapping the files behind the scenes. So you have, we always read the nozzle loads.xlsx. So you can copy and paste that file and make multiple copies. For instance, I can copy paste and call this scenario 1. And once I start the program, it reads the loads from here, and I can swap the file and use always the file that is named nozzle loads. Also for the attachment in the preliminary report, allowable stress is only shown when the component fails. You can see the acting stress component. Okay, I kindly ask you to submit these questions about the attachment to our support team, and we will look into that in the coming days. And I think we can improve on that area. Thank you for your suggestions. And of course, you can send a custom customer request from Ask for Support from here. This is a bit more of a suggestion than a question about how to do something. So that's why I'm asking you to please send via Ask for Support. Okay, so we had made some correction, particularly concerning the calculation of the C1 coefficient for 82,000 YouTube tube sheets, and also a correction in terms of corrosion and tolerance consideration in EN 1591, and we corrected an error that was present for cones in ISME Division 1 concerning the diameters in different points. We also had some problems with customers starting up the program, having issue opening files or even starting the program itself, or dimension of windows that were behaving a bit crazy. So we fixed all of that, and as always, we have a list of changes available on our website. Everything else, we have added opening on flatheads according to Division 1, UG, 39D, and E. They are additional calculation that can be performed now. The tightening torque for flanges calculated according to EN 13445 Annex G or EN 1591 can be now calculated according to the Annex G 84. This is useful for our Italian customers, but VSR added the possibility to use a custom hydraulic test that is lower than the one calculated by the calculation code. That is in contrast with what's happening in other codes, but according to the Italian code, it is possible to use this under certain circumstances. And in the next release, we have added the customizable lowest stress ratio for every code. So if you have a component that is determining the lowest stress ratio that is not modeled inside NextGen, you can insert the lowest stress ratio and determine the hydraulic test pressure by using that. For our large companies, customers may be interested in the fact that you have now new command line installation options. So if you need to distribute NextGen on multiple computers, you can manage it by distributing via command line. We have a new way to calculate threads, also available for ISME calculations. The sight glass calculation that is peculiar to the Italian code is now extended to all the calculation codes, so it can be useful to use this way to calculate sight glass also in other methods. We added the fatigue screening according to division 2 to ISME division 2, and I think also available in division 1. And we finally improved the export of 3D models. So if you need to export your 3D model from NextGen to your 3D environment, please make sure that you have enabled the BREP models in the export options, so you will end up with a more precise model. Okay, I think that's a wrap. Thank you very much for your patience. And if you have more questions, I'm available for in Italian in the chat, the Q&A section, and we will answer that. And also, you can now open your microphone if you want to talk directly. Let's see if we have something here. Can half-pipe jacket of cylinder and dish be merged? Ah, that's interesting. No, it is not possible to merge. So to use a single coil that goes on top of the bottom head and onto the cylinder, but okay, I don't think it will be available also in the future. Because it's a bit difficult to model that component, but we will look into that. We have a question here. Recently designed the tank according to division 1, all materials according to section 2. I wanted to use EM materials to anchor the skirt. I didn't find an option to add such materials in this module. It is possible. Okay, so you have made a calculation according to division 1, and you are when you are working with ISME, you depend on the materials that ISME publish. So we can't include more materials in the ISME database. Probably the solution will be to add a custom material, right? Yes, exactly. If you have both the licenses for ISME and EN, you can copy the values manually. There is not a straightforward way to do that, but you can copy that from those values from the EN database and create your customized material. Maybe you can check ISME section 2 to check for the rules to be applied in this case. You're right, but this is only for anchoring. So in your opinion, this is outside the scope of ISME division 1, and you should be able to use those materials. The problem here is that we don't have a straightforward way to calculate the allowable values in ISME. Maybe we can follow the rules of section 2. I don't see it in the near future an inclusion of foreign materials inside our ISME database. Maybe we can think about an import function that help you in filling the values, but it will always be a custom material because you have to make assumptions, and the fact that you are using a custom material place you in front of the decisional process to use a material that is outside the provided database from ISME. Let's see if we have more questions here. Okay. Okay, I think that's it. If there are more questions, please feel and ask for support from the software itself. Thank you very much again for taking the time to spend an hour with me with this presentation, and I'll see you next time. Thank you.